we're standing next to a creek. And as you can see, we're talking about mobile soil generation and erosion. In this case, you can see a river system, which is transporting sediment during flood conditions. There's also floodplain accumulation, whereby sediment is dropped out in a floodplain whenever the Reynolds number drops below 1. Beaver dams used to populate this system, and as you can see, these thickets would have been perfect material for the production of beaver dams. Hortonian overland flow, which will be covered later, can also occur in a region like this when heavy downfall of water occurs. This would occur whenever a secondary channel would come into the stream that is not normally flowing, but whenever the amount of water that is entering the system exceeds the capacity of the soil to absorb the water will flow overland and will enter the stream. This can both transport sediment and later downstream under the right elevation and slope conditions deposit. Wetland ecosystem, as you can see, with a 3 to 5% grade. There's a lot of water at the surface, and there are cattails behind me. This likely would have had beaver all up and down it prior to the arrival of the white man. In this system, there is the accumulation of organic matter here, as well as you can see there are some tracks in the ground from cattle. This is a bioturbating process, as well as the interaction of gophers further up the slope, which is not directly observable here. These serve to en masse move sediments downhill and create a mobile soil. In addition, this water that's moving downhill transports ions through the process of alluviation, whereby mobile ions like calcium, magnesium, and iron are moved from the micas and the feldspars through the water down into the river systems. The generation of mobile soils often begins at the bedrock interface. A condition known as saprolite occurs whenever bedrock weathers by chemical and physical processes. This can occur at the surface, or it can occur beneath the surface, whereby the interaction of acid water degrades the chemical structure of bedrock. In this case, the 6 Mile Formation, which is a coarse pebble conglomerate, interacts with water, and the matrix structure of the conglomerate degrades and turns it into a mica and feldspar-rich soil. This soil then moves downhill to the previous location that we filmed and generates a wetland ecosystem. This bedrock is highly porous, and much of the water that we saw down at the wetland ecosystem communicates through this bedrock. Additionally, the interaction of trees and other forms of life can help to bring to the surface chunks of partially weathered saprolite or chunks of bedrock that have been broken off, and this can aid and accelerate the weathering process. Here is some evidence of bioturbation. These holes come from small burrowing rodents. Now, whenever they burrow, as you can see, their detritus comes out and moves en masse downslope. This causes the generation of mobile soils. Water moves from the subsurface out here to the surface, and then back into the subsurface down here. In doing so, ions are both removed from the soils and then re-entrained in the processes of alluvation, as I mentioned earlier, and illuviation, as I am mentioning now, where mobile ions are entrained into the soils. Additionally, this water, which is at the surface or which is very near the surface, freezes and thaws multiple times during the season. This increases the weathering of subsurface bedrock, saprolite, and regolith, and serves to generate a more mobile. Here we can observe a process called a tree throw. As you can see, this area has been lifted like this, as this cottonwood tree is beginning to lean to the northeast. This is another process by which soils can be reworked, and if the bedrock and saprolite is close enough to the surface, chunks of that weathered bedrock or that saprolite can be brought to the surface. This is another method by which mobile soils are generated and by which they can be moved downhill in a slope position and eroded. Here's another example of a tree throw. And as you can see, the horizontally branching root system has upturned a bunch of soils. This is another method by which mobile soils may be generated and eroded. As you can see, it's a lovely day outside. It's about 40 degrees Fahrenheit. But underneath of this chert nodule, there is some frost on the spider web. This is indicative of the retention of cold air and water within the soils, again contributing to that frost thaw cycle. Steepened slopes like the one that I'm sitting on are being undercut by the ephemeral stream behind you. This ephemeral stream only flows under flooding conditions. When it does flow and when it floods, this usually indicates that there's large quantities of water falling from the sky. Whenever this happens, it saturates or supersaturates the soils that are being eroded from this highly fissile bank material here. This happens to be a Miocene ashfall deposit. This highly porous material contributes to the debris flows which the videographer is currently standing on. As you can see, there are many cobbles from the 6 Mile Formation which caps it, which are coming down as this material flows in a mass movement downwards. This is another mechanism by which mobile soils may be generated and may be eroded, as these soils are generated whenever the stuff erodes from the top, from the bedrock, and they are eroded whenever they are undercut by the stream. Here is more evidence of bioturbation at the surface. These are the gopher mounds that are indicative of their pushing out of material from their burrows. As you can see, the material is distributed in sort of a teardrop shape with the leading edge of the teardrop pointed downhill.